Good morning. Welcome to PCI's first webinar Wednesday of 2022. On behalf of the Powder Coating Institute, thank you for joining us for today's webinar, Understanding the NFPA and IFC for Powder Systems, presented by Marty Kurecki with AXA Nobel Coatings. Before we get started, I want to remind everyone that all attendees are on mute, so if you have any questions along the way, please type them in the questions panel. Marty will address all the questions at the end of the webinar. If we run out of time, there will be contact information on the closing slide if you have additional questions. This webinar is being recorded and it will be available through the PCI store within 2 business days. All attendees will receive a brief survey after the webinar. Please take a few moments to reply. We appreciate your feedback as PCI continues to develop new programs to offer the topics and trainings you need. Now I'd like to introduce the presenters for today's webinar. Marty Kurecki is a business specialist and commercial quality manager with AXA Nobel Coatings. He has over 35 years of experience in the powder coating industry and has served in a variety of roles, including powder formulation, technical service management, field sales, and marketing. He holds several domestic and foreign patents resulting from his research in powder coatings. As an educator at heart, Marty is often sought out to provide training to the powder coating industry. He's an active member of many industry organizations, including a member of the PCI Board of Directors. He also participates on several committees with the Chemical Coaters Association International, the National Association for Corrosion Engineers, the Society for Protective Coatings, the National Fire Protection Association, and International Codes Council and ASTM. Marty, thank you for being here today, and I'm going to turn it over to you.
Thank you very much, Kelly. Today I want to hopefully present some information that will make understanding the regulatory world of powder coatings a little bit easier. There's 2 basic standards or codes that define how we should operate within the powder coating industry, and it's all safety related. One is the National Fire Protection Association standard for spray application using flammable or combustible materials. And the other is the International Fire Code, which is part of the International Code family. And so we're going to go through those, and I'll also touch a little bit on OSHA and the OSHA regulations that we have. So these are the 2 standards that want to talk about, or this is the NFPA version. A little bit of history for the NFPA. It began in March of 1895. A group of men got together in Boston, Massachusetts, and they represented the sprinkler and fire insurance interests. Within 100 miles of Boston, there were 9 different standards for piping and sprinkler spacing, and that caused great problems because none of them were very effective. In March of 1896, the group met again, and they created an automatic sprinkler protection, which eventually became NFPA 13 that you see on the screen. In November of 1896, they again met in New York, and the NFPA was chartered, but at that time it was only limited to stock fire insurance organizations and representatives of such organizations having charge of the improvement of those inspections. 1904, an annual meeting, they opened the membership, and other folks such as Factory Mutual Insurance Company, Electrical Contractors Association, the American Water Works Association, International Association of Fire Engineers, which is also the International Fire Chiefs Association, the American Society of Mechanical Engineers, and the American Institute of Architects all got involved. And pretty much today, the way NFPA is devised, we have 1 full-time NFPA person on that works with us on our standard, and then the rest of the committee is made up of volunteers again, through many of the organizations in the industry. And they have a maximum number of people that can be in each of these organizations. Despite the term national in NFPA, it's really a global or international organization. In 1903, John Smith of the Sun Insurance Office in London joined. George Smith from the insurance office in Sydney, Australia joined. And Nicholas, I'm going to screw this up, Sagowski, an insurance engineer in St. Petersburg, Russia, joined. The biggest code that we probably all know from NFPA is the National Electric Code, or NFPA 70. There's actually 3 versions of that. There's the NFPA 70, NFPA 70B, which is the electric code for industry, and then 70F, which is another code used for industry. The IFC, on the other hand, its history started in 1994, was part of the National Prevention Code, Standard Fire Prevention Code, and the Uniform Code, our Uniform Fire Code, were all merged together to create the IFC. And it was first published, and this is interesting, in 2000. So while a lot of our AHJs, and we'll talk about an AHJ, that's authority having jurisdiction, use the IFC, there's a confusion as to which one people want to look at. It's noteworthy that the standards published by the NFPA are a little bit different than the IFC. The fire codes in the IFC talk about the what of the situation, and the standards that NFPA put together are the how. And so both the IFC Chapter 9 and NFPA 1, and NFPA 1 is the National Fire Code, work together, and they address all of these issues together. Because different non-governmental agencies develop them, they're often overlap in their requirements, and in some cases, not often, but in some cases contradict each other. And so what we try to do is we try to educate the industry and the AHJs to be able to use both of these codes to understand where to go and how to look at the industry. Again, NFPA has 75,000 members, over 100 nations in it. There's over 6,000 volunteers, such as myself, that serve on the NFPA. And we sit there and develop these codes over time. The process is about a 3 to 4 year process, depending on the code. The current standard for NFPA 33 is the 2021 edition. The International Fire Code is the 2020 edition. It takes that long to get public input to work through the various sections and try to update the codes. Here's 33, standard for spray application using flammable and combustible materials. There are some other codes that we use in our industry, in the powder coating industry. NFPA 68, standard on explosion protection by deflagration venting. NFPA 86, which is the standards for ovens and furnaces, and a little bit of 654, which talks about fire prevention for dust explosions. And we'll talk about how NFPA 654 gets misunderstood when it comes to 33. The Chemical Safety Board tried to push organizations to, or push the government to come up with better standards, because we were having dust explosions in industry. Many of those dust explosions were from sugar refineries and others, and didn't necessarily translate to powder coating, but the process of the explosion or the fires were the same. So they pushed the government and said, hey, we want NFPA, because they're a great organization, to create a standard that encompasses all industries that have combustible particulate solids. And so if you look at NFPA 654, there's a section in 654 that says you need to do a dust hazard analysis of your facility. And so a lot of people think, gee, if I use powder coatings, I have to do this dust hazard analysis at my powder booth, so forth and so on. But if you actually read 654, it says NFPA 33 is the standard that governs the processes around the powder booth. But if the powder gets out beyond the coating operation, 654 would take place. So kind of a different way to look at it. Here's the IFC. Again, it came from the International Code Council. They have the International Building Code, the International Fire Code, and that's why a lot of the AHJs reach out to the IFC, because it works hand in hand with a building code. And so who are our typical AHJs that we have? Occupational Health and Safety, OSHA. They certainly have governance over all of this. There's a standard 29 CFR 1910-120, I think it is, which is the standard or which is the regulation for the powder industry. That was actually adopted from an older version. I think it was about a 1975 version of NFPA 33. And that's the current law that we have to follow. Other AHJs, we have local fire departments, and that could be a fire chief, a fire inspector, a fire marshal. All can come out and do inspections and either turn down a permit or cease operations. Oftentimes it's a local building inspector. And again, that's where the International Building Code and the International Fire Code work so well together. And then there's some confusion about 33, but those two work hand in hand, and the building inspector will come out and again look at this. And of course, last but not least, insurance companies. They want to protect the process that we're using, and so they have interests in doing that, so they can adopt NFPA 33, the International Fire Code, portions of each to be able to hold us accountable for safety within the industry. The biggest problem with most of these, and I'll talk from the fire department side, as I spent many years as a volunteer fire fighter, engineer, and line officer, we were never taught about coatings during fire school. Building inspectors aren't taught about coatings during their building inspectors courses that they take. Insurance companies certainly don't know that much. The problem is that they have to rely on these standards and codes that are written to be able to then understand how they need to govern where we are. And part of the education process that PCI and CCAI and other organizations are pushing is trying to educate the AHJs as well as our industry together to understand the processes. And so we work very well hand in hand to do that. Here's NFPA 654 again, trying to talk about the combustible dust. You can see the two pictures that we have here. The one where the upper picture where the fire's on the coming out of the powder guns. I did a quick video that we'll see here in a minute, and we'll explain how that works. And then the bottom one is actually just a torch trying to burn powder that's in a box or in a pile. And we'll explain that here in a second. Obviously, we don't want to see the picture there on the right, and I always got a kick out of the guy that's trying to peek around the corner there and look in there. I wouldn't want to do that if I was him getting that close. But again, here's the information on the Chemical Safety Board, where they identified 281 combustible dust incidents, and they tried to push the government to say, hey, we need an overarching standard that we can help here. So that's where 654 was adopted to be able to do that. So again, the simple fire triangle that we all know and had learned long ago, we need oxygen, we need an ignition source, and we need fuel in order to have a fire. And if we can eliminate any one of those three, we don't have a fire. And while we use terms like minimum explosible concentration for powders, and AHJs read a data sheet that says the powder can, when mixed in air, become combustible, and we talk about, you know, dust enclosures and all that, we're worried about explosions. And so, you know, they get very defensive right away, but they don't understand that the process really is a safe process overall. If we look at the statistics in the industry, there are very, very few incidents that we have annually with regard to powder systems. And most of the ones that we have are due to, I'm going to say, operator error. An example would be, you know, our local waste department says, gee, in order to throw powder away, it needs to be fused in a block because we don't want loose powder in a landfill. So people take boxes of powder and they put it in the vestibule of the oven so that as it heats up, it starts to cure in the box so they can throw it away, and then the box catches fire. And that's where a lot of the issues come in. So what we want to do is we want to try to take these away. And in our world, the biggest one that we can take away, fuel's always there because we're always coating parts. Oxygen's always there because that's the you know, what we breathe. The ignition source is the big one. And so that's why we continually push grounding of parts, grounding of objects, grounding of operators in our system, because if we take away the ignition source, we don't have the fire that we have otherwise. So I did a real quick example of the combustibility or the flammability of powder. I basically took some powder, just a standard polyester powder, and of course I'm using a torch, and you can see where as the powder starts to melt and catch fire, it quickly extinguishes. I go back and I try to get it burning again a lot, and it starts burning, but notice that it self-extinguishes. And that's pretty much what happens with powder when it's not in the air, it's not in an airstream. I did another example here where there's a cup that I'm holding. My son's holding again the torch, and all I do is I let the powder go through, and you can see how quickly that powder catches fire. And I'll run this again so you can see it again, how quickly that powder catches fire and comes up towards the cup. And so the idea is, if we can eliminate the ignition source by making sure that we have grounded hooks, grounded parts, we don't have an area where we can have that ignition source, we certainly have a much safer operation. NFPA 33, the IFC, and the OSHA regulation all say that we need to have, and this is a typo, I thought I had fixed it, I apologize, it's not more than 106 ohms, it's actually 10 to the 6th ohms, or 1 megohm of resistance on our parts. And the reason that we do that is that if we have grounded parts, and it helps you in application of powder, right? The better the grounded part, the better the attraction is. So our transfer efficiency is better. But we don't have arcing and sparking in the booth because we have poor ground. And so as long as we have good ground, we don't have the arcing and sparking, and that takes away the ignition source. Racks and hooks, obviously the one on the left is a very heavily coated hook. The more contact points we have, the less chance, or the more chance we have of increasing the resistance, and therefore having an ungrounded part It's best if we had square stock and we bent the square stock so that the point is up. That always helps with the contact points. I've had a lot of people ask me, well, how many times do I have to run, can I run my hooks around before I have an ungrounded part, or I exceed the 10 mega or 10 to the 6th mega ohm or ohms or the 1 mega ohm? And I say, I don't know. I can never answer that question because it all depends on your operation and how it's done. Start with a grounded hook, right? One that's clean, bare hook, hang it on your line. And where do we need to look at the ground? The most important place is in the booth. It's not really important at your washer. It's not really important in the oven, but it's important where the powder is being sprayed because that's where the fuel for the fire is. So you hang your racket hook on there, then take a meg ohm meter because you have to use 500 volts or more of electricity in order to get a good circuit through that. Use your meg ohm meter, measure your resistance. Coat your parts, run it around, take that same hook and measure the resistivity. And do that until you get to 1 meg ohm, and then you'll know exactly where you are with how many times that hook has to go around to do that. In chapter 12 of NFPA 33, we talk about handheld electrostatic equipment. And of course, it says the high voltage circuit shall be designed so that they cannot produce a spark capable of igniting the most hazardous powder air mixtures. And of course, when we talk about powder air mixtures, we talk about the limits at which powder will burn. If we don't have enough powder, just like with propane, if you have natural gas or propane, if it's too lean, it won't burn. If it's too rich, it won't burn. So there's an optimal amount. And so you saw when I put the torch into the powder, it's too rich. There's too much powder there. Yes, it'll catch fire. Yes, it'll burn. But as soon as you remove that torch, the fire goes out. If it's too lean, there's not enough powder there to burn, so it won't happen. So we want to make sure that we stay below that minimum explosible concentration. And many people ask me what that concentration is, and I'll show you some information that we can find in there. Another question that I get often is the term between listed and approved. A listed device is one that has been tested through organizations like Factory Mutual, where they certify that that particular piece of equipment is safe to use, and that becomes certified. An approved acceptable piece of equipment is one that the AHJ, the fire marshal, OSHA, somebody else, the building inspector has deemed okay to use, and so now that is approved. And the two aren't synonymous. They both can be used, but again, they're a little bit different in terminology. If we have an automated system, meaning parts on a line where we have automatic guns that spray, and we don't necessarily have to have an operator holding the gun or actually triggering the gun. NFPA requires that we have a automatic powder system, an optical flame detector, that when it sees a spark or flame, it will automatically shut down the powder system within 1/2 second. A little bit of confusion between the liquid side and the powder side. In the powder side, we want to shut everything down. That includes all the ventilation and so forth. In a liquid system, we want to keep the ventilation on to remove any of the flammable vapors that are there. Powder system, we want to shut everything down. And of course, we then reach out to NFPA 72, which is the National Fire Alarm and Signaling Code. Again, talks a little bit about the optical flame system, shuts it down in 1/2 second, stops the conveyor, stops the ventilation system, turns off the powder, turns off the collector. So absolutely nothing happens and nothing goes anywhere. Everything pretty much stops. And here's just some pictures of the controls that are out there. If we talk about a ventilation system, Ventilation system can be whether you're spraying and the powder goes to a bag house, or you're spraying, from the booth goes through ductwork to a bag house, or whether you have a cyclone system. These are now closed systems versus a cartridge collector that is an open system. And so we need to make sure that if there's an issue, that if there's an explosion in the bag house, for example, that flame does not come back into the building. So we have slide gates and dampers to be able to help with that. Fire suppression, NFPA 33 says that you have to have fire suppression in all coating booths, whether it be manual or automatic. And that fire suppression can be a number of different things. It can be water, it can be carbon dioxide, it can be automatic or dry chem, it can be a number of different things, but you have to have it in there. In the recent edition of NFPA 33, we did put in an exclusion. Booths that are smaller than 9 square feet or maximum of 3 feet in one dimension do not have to have fire suppression in the booth. And that was done because many of the OEMs, almost all of the powder producers, a lot of smaller groups may coat 2 or 3 panels to make sure that the color is right, the gloss is right. They can do testing on those panels, and it's not the same as an entire operation where powder's being sprayed all the time. It's a single manual spray gun. Portable fire extinguisher has to be there, and overspray of the powder is directed towards a dust collection system. So there's really not a lot of residue or extra powder there. So we eliminated having to do that. That was a huge step in the process. And I will tell you, it took a long time to debate that within our organization. Air requirements, where non-deposited air suspended powder or powder overspray is conducted by ductwork, sufficient airflow needs to be provided to maintain less than 50% of the minimum explosible concentration. Now that's important for a couple of reasons. One, you want to make sure that there's not enough powder in there, it's too lean to catch fire. If in fact it wasn't too lean, then we would end up having to require sprinklers or some fire suppression in ductwork. And so it may not seem like a lot, but now when you start to design the ductwork, you have to design the ductwork to withstand the weight of water should there be a fire. So now all of the supports, all of the ductwork, everything else has to change. And of course, if you don't know what the MEC of the powder, it says that you can use 15 grams per cubic meter or 0.015 ounces per cubic foot, and that goes to the minimum explosible concentration. And so some time ago, we were sitting at an NFPA meeting, and we're looking at, and this comes from the annex material. We were looking at the annex material and saying, wow, this data is really, really old, because we had some powders in there that we haven't, chemistries that we haven't used in years. And a girl who was sitting there that worked at Factory Mutual said, I have all the test equipment in the world, but I don't have any powder. And I went, I have all the powder and I don't have the test equipment. So we put this test matrix together, and you can see where the MEC of powders really don't change all that much. And yeah, we may have some that are in the 45 gram per cubic meter range and some at 115. But all in all, that's a small range when you look at the possibility. We also used bonded, blended, and extruded aluminum pigments in there, because everybody thought that, gee, if we have a metallic pigment, it's worse than the rest. And when you actually look at the data, no, it's not. You can see that if you're using a white, for example, something that has a lot of pigment in it, the MEC is a whole lot different than if you use something like a clear. And that's pretty standard through the various chemistries. So we have epoxies, we have polyesters, we have epoxy polyesters or hybrids, and we looked at all of those. And so for the most part, powder, looking at this information, is fairly safe. And I get all the time, I get questions on, can you provide the MEC for a powder? Can you provide the KST or the Pmax? And that has to do with the how quickly it flashes off, or how it will, the explosion parameters when doing this testing. We look at that and we go, okay, no, we don't have that. And if you look at most powder producers, they make thousands of different products every year for the industry. Excuse me. And to be able to do that testing is one, next to impossible, because we can't do that much testing, and two, it'd be too costly. So we don't do that. We have some relative data, and that's why the NFPA says, gee, if you don't know what you're using, or if you're going to use a multitude of different colors and keep switching back and forth, you can use a figure of 30 grams per cubic meter as your MEC. So that covers you in all ways. And you notice that we don't even approach 30 grams per cubic meter in any of these. So that's pretty good. So in an open system, this is what would happen. If nobody's ever been, to a facility that had a fire, congratulations, that's fantastic. I've been to 2 facilities where a fire has occurred while I was there. It's a rather unique experience when the powder, or when the fire happens. In one case, it was a handgun. And it was rather interesting. The operator kind of stopped spraying, shook the handgun off, and went right back to spraying again. And within 5 minutes, it caught fire again. And I'm like, stop, what are you doing? And so we had to fix that. And again, it was a ground issue. Simple as that. And the other was an instance where it was a continuous line, and they used a carbon dioxide system, so it didn't put dry chem in the powder, so forth and so on. And as soon as the system went off, everybody kind of stood there. The operators knew what happened because this had happened before, and they're starting out, the alarms are going off, and everybody's trying to figure out what's going on. But it's rather interesting. And of course, I've been involved in a couple of investigations of fires. And in almost all cases, grounding was the biggest issue. If we have the open cartridge, all we have is a fire. If we end up getting into a bag house or an enclosed system, unfortunately, we can end up with an explosion, because the fire has to vent. If it's closed, it will vent one way or another, and that's what we're trying to avoid. And then it talks about enclosures in the section on powder in chapter 15. They shall be listed, so forth and so on. They should meet NFPA 68, which is the deflagration system, and fire suppression in NFPA 69. And of course, there's ways to be able to vent all of that so that we make sure that we don't have the issue. In this particular case, you can imagine that the fireball is going to come back through the ductwork, back into the building. We certainly want to stop that, and that's what those vents are there for, to stop that possibility. And of course, you can see the deflagration vent there at the top of that particular system. When external venting is not feasible or desirable, such as where location of equipment outdoors, so forth and so on, we need to do this venting, which brings me to another point. We talked about AHJs and all of that. We had an AHJ in the Carolinas, and I don't remember which one it was anymore, where they wanted to buy a typical freestanding cartridge collection booth, but their local regulation said that it had to be vented to the outdoors. Well, there's no way to vent that booth to the outdoors because it's all combined. And so even AHJs have difficulty sometimes understanding the differences and so forth. NFPA 654, again, as long as we do housekeeping, as long as when we're spraying powder stays in the booth, and all of my friends in the industry that make equipment are very adept and very good at making sure that the designs are there to keep powder in the booth. The problem is we tend to add more guns, we tend to have our filter media blocked up, and occasionally powder starts to drift away. Once that happens and the powder starts to drift and it starts to get outside the confines of the coating system, NFPA 654 jumps in and says, hey, you can't have more than a 16th inch or the thickness of a dime on powder anywhere, whether it be the floor, the rafters, or otherwise. Because when we get to that explosion that you saw in that the collector, that'll rattle the building. And as soon as that rattles the building, then all the powder that is on the rafters and everywhere else starts to come down, and you have a secondary explosion. And while that first explosion is a concern for the outside, typically not many people are there, but now when the secondary explosion comes inside where the operators are, that's a concern. And that's why they want you to do a dust hazard analysis to make sure that you don't have dust greater than the thickness of a dime anywhere in the system. So all in all, the idea for understanding NFPA or IFC is to, if you're going to do a new system, one, communicate to your equipment people, communicate to your powder supplier, communicate to your AHJ. If the AHJ doesn't understand, then reach out to your equipment people, your powder people, your folks here at PCI, and we will help you talk to these folks and understand the differences or understand the standards so that you don't get to the point where your system's all set and ready to go and the building inspector won't give you a permit, or the fire department won't let you start up, or your insurance company says we won't insure you. So we want to make sure that all of that is done way up front so that we don't have those issues. Always want to be there to be able to support everybody in the industry. I personally would like to thank PCI and the Education Committee, Marty Sawyer and her webinar group for allowing me to do this webinar. Kelly, LeCount, and James, thank you so much for the support in putting all this together. My friends at the NFPA and the IFC, my powder producing partners, and my equipment folks that I serve on the NFPA and these other organizations with, without all of us working together, this wouldn't be possible. So I want to thank you all. Couple of notes. March 7th through 9th is our powder coating week in Orlando. Many of the people across the country are feeling the freeze, so come on down to warm Florida when you get an opportunity. Enjoy the time down here. Powder Coated Tough magazine, the 2022 Buyer's Guide is either out or soon to be out, as well as Powder Coated Tough. Great journals and magazines that can certainly help you out with a lot of information. They're free. All you have to do is sign up for them. We're actually putting Powder Coated Tough in a Spanish version. So if you have, if you're a company that has Spanish speaking folks, make sure that you get a copy of both so that you can pass that along to both of those folks. So I want to thank you. At this point, we'll try to answer any of the questions that you have. If you have any questions after this, certainly feel free to reach out to PCI. Kevin Corson, our Executive Director, will be happy to field your questions, and he will either get them to me or someone else that can answer your questions and get you an answer as quickly as possible.
Thank you so much, Marty. That was really important information, of course, and a wonderful presentation. We did get a couple questions in here, so I'll just jump right into that since you went over all of the other PCI information for us. Thank you so much.
Sure.
So here we go. Regarding section 12.5 of NFPA 33,
Okay.
if the gun handle of an electrostatic sprayer has no metal parts, is it a grounding wrist strap suitable, or do you think metal strap on the gun handle should be added with the ground wire to the metal strap? And that would later require conductive gloves.
Okay, so that's a great question. Section 12.5, Chapter 12 is handheld electrostatic spray equipment. 12.5 is grounding. And there are 5 sections underneath that. By standard, it says 12.5.1, the handle of the spray gun shall be electrically conducted to ground by a conductive material. While it may not be metal, I don't know of an equipment manufacturer that does not have a material that allows that for grounding. The answer to your question about a ground strap is yes. We want to make sure that we do that. It's important that the employees are grounded as well, because if they're not, here's what happens: is you pull the trigger on an electrostatic spray gun. This is a typical Corona spray gun. There's a point at the end of the gun where there's a Corona. That Corona, you know, we put 100,000 volts or thereabouts out to that Corona at a very small microamp. It electrically charges the air in front of it. That's electrically charged negative, and the powder goes through there, picks up a charge, and then goes to the part. Anything that gets in that Corona field now will start to pick up that charge. If you're not grounded, the parts aren't grounded, those become capacitors. In other words, they start to store that energy. And for anybody that's worked in the coating industry knows that if you're not grounded, the next thing you do, you reach over and you grab something that is, and you get sparked or shocked. And so somebody standing on the line getting shocked all day long certainly isn't what we want to do. So we want to make sure that they're grounded. And yes, a ground strap would be perfect for that if the handle of the gun is not producing that. When you start wearing gloves, that's where we now put a barrier between the hand and the pistol of the grip. And so now we've stopped that flow of electricity, and we've stopped the ground. So a wrist strap will help overcome that. So that would be perfect.
All right, great. Well,
Marty, I just want to add, so this is James from PCI. I do know that several gun manufacturers, the handle itself is a grounding point. And
it's supposed to be, yes.
Yes, it is. So I would just also check with your gun manufacturer to make sure that that is.
Yep.
Nice.
Thank you.
Thanks.
Sure.
All right, next, is a fire suppression system necessary even if we have a fire detection system in place and make sure to eliminate one or all of the 3 sources?
Yes. NFPA, and people want to know, when did NFPA start requiring fire suppression in a booth? It has always been part of the standard. Fire suppression is there because we can never completely eliminate any of those 3. We always have the fuel, which is powder. We always have oxygen. And if you're doing electrostatic spray, you've always got a chance for a spark hazard. So yes, the only time that it's not is what I covered in a booth that's 9 square feet or smaller, and that is 3 feet in any one direction. And just so you know why the 3 feet, the 3 feet has to do with the sprinklers that are typically in an occupation. If you have an overhang of greater than 3 feet, the sprinkler system won't get back to the far point of that area.
Okay, good to know. Is it recommended to always utilize listed equipment to avoid problems?
That's a loaded question. I'll just say that. over my many years, I've been to many facilities where they have done an outstanding job of creating or building their own equipment. I don't want to say that a listed piece of equipment is safer than the ones that they have built. It's up to the AHJ as to whether they allow that piece of equipment to function or not. We know that listed equipment has gone through all of the safety testing so that we know it's okay. We would certainly hope that if anyone builds their own equipment and it's approved by an AHJ, that there was some testing involved that allowed that piece of equipment to be approved at that point in time.
Okay. Couple more here before we conclude. We have an older model dust collector that has a blast panel which vents through our roof. Does this still meet code?
Yes, it does. It vents to the outside, and that's what the standard says. Again, the concern, and you saw the picture of the dust collector that was exploding. If you have it vented to the outside, that's what you need to do. Are there better places to vent than to the roof? Maybe. I don't know your building structure. I don't know, what's to the side, so forth and so on. But yes, it should meet code if that indeed is the case.
Great. All right. Is a powder coated metal exempt from an automatic oven suppression system per IFC 3006.1 due to lack of combustibility?
Well, I knew we were going to get into this question. The problem with IFC and the problem with NFPA 86 is a powder oven is considered a Class A oven. In NFPA 86, they're saying that powder gives off 9% volatiles during the cure process, which we all know is not the case. There's been many studies and testing done to show that that's not the case. And so that has been pushing a lot of the folks to, a lot of the AHJs to say, I want fire suppression in ovens.
Okay.
In this particular case, the question was asked, we already have a coated material and it's going through the oven. Do we still require that? That is an AHJ specific requirement. Because it's a Class A oven, if you're using that oven for curing powder, so we have a part that's just powder coated, not cured, and then sent through, yes, it would require that per IFC. If you're just using this for another application, then you would have cause to go back to the AHJ and say, hey, we don't really meet that criteria. Can we talk about what we need to do? It's a gray area. It's one that really you need to have a discussion with your AHJ.
Okay, very good. If you have a very small automated fluidized bed, is fire detect or suppression required?
Okay, so with a fluidized bed, we don't have the same ignition source that we have with an electrostatic spray. We don't have the spark. However, a lot of AHJs require fire suppression in a coating operation. I do not believe, and I would have to go back and look, that's a great question. I do not believe that would require fire suppression in that particular case. And the question then becomes, Is the fluidized bed in a booth or is it outside of a booth?
Okay. Well, Marty, we do have, we have the askers of the questions here, so we can certainly get more information out to Jeremy and, you know, continue any conversations if necessary.
Certainly, and
Yeah.
you know, I'd be happy to speak to anybody that had a question in
Yep.
further detail, and I will certainly get you an exact answer for any of those questions if I didn't answer it sufficiently here.
Perfect. Well, we can certainly get that out to all of the attendees as well if they contact us. One more real quick, since we have a few more minutes left. If we are losing ground from our conveyor chain to our hanger, is it an issue to add a rub rod to induce ground at the booth?
No, it's actually a very commonplace situation. So what typically happens? You know, you have an overhead conveyor which sits just above your powder booth. As you're spraying, depending on how things go, you've got, you know, the chain oil on the conveyor. You've got some other things there, and you can very easily lose ground on that conveyor system. There are an awful lot of folks that will put a rub bar in. And basically what a rub bar is it's a piece of metal that's kind of bent at an angle so that as the parts come in, they hit this piece of metal and they rub along the metal as it goes through the booth. That piece of metal rod is then grounded so that it now has the conductivity between the rub bar and the hook so that then your parts are grounded. The biggest concern with all of that is one, making sure that the rub bar stays clean, and two, your hooks and racks stay clean. But yes, that is an acceptable means of grounding. Great question.
Yeah, so then just a follow-up comment here and question. Rub rail is a good solution. However, they don't often add a potential contamination source. Wouldn't it be better practice to fix the ground? So,
well, it can cause a contamination source. You know, again, anything can cause a contamination source. You have to be careful of what you're doing. You know, in the powder world, we coat anything from Class A parts, i.e. the hood of your automobile, to, you know, parts that are coated for protection of the metal, and we really don't care what the appearance characteristics are per se. So it all depends on your process. If you have a Class A operation, you're going to have good, well-grounded parts because you need to keep everything else so clean that you don't have that issue. If you're coating something that's not as critical, you may have, you know, the use of a rub bar. So again, yeah, it all depends on your situation and the way your operation is run.
okay. Well, very good. Thank you again, Marty, and thank you everyone for attending the webinar. Just another reminder of Powder Coating Week, March 7th through 9th in Orlando, Florida. All the details, registration information, and program descriptions can be found at conference.powdercoating.org. And if you would all please watch for the link to our survey and give us your feedback so we can continue our webinar offerings and programs that will benefit everybody. Thank you all and have a great afternoon.
One last comment on those surveys. Please be honest. If I get copies of the surveys and I get constructive feedback, I will change my presentation to help address those issues so that future presentations take all that into account so that I give the best presentation possible. So I appreciate any comments that you have.
Terrific. Thanks so much, Marty.
Thank you.
Take care.
Bye-bye.
Bye-bye.